Hey friends, click on subscribe button and tap the bell icon to never miss another update from Padhakooo. This lecture on Thevenin Theorem is presented by Padhakooo, your free way to success. Thevenin Theorem. Topics to be covered in today's lecture are: what is Thevenin Theorem? Why do we need Thevenin Theorem? What is Thevenin Equivalent Circuit? And how to calculate Thevenin Equivalent Circuit parameters, that is Vth and Rth. And some numericals regarding Thevenin Theorem. So let's get started. Suppose we have a circuit as shown. In this circuit, if we have to determine the value of current, we cannot directly use traditional method to solve the circuit. Yeah, we can use it, but will not use, because as it will be very lengthy and time consuming and maybe errorful. So to simplify this kind of circuit, we use network theorems, and today we'll be discussing Thevenin's theorem. According to Thevenin theorem, firstly, this circuit has to be divided into two parts. First is the main circuit. This is main circuit, and another circuit is the circuit having load resistances. This is the another circuit having load resistance. This is load resistance. Okay, so we name both the circuit as circuit A. This is circuit A and this is circuit B. Okay, now only network A is to be drawn and taken into consideration. This is network A, which is taken into consideration, and open circuit voltage is defined across this particular network, which is VOC. You can say that VOC is the open circuit voltage. Open circuit voltage. And this circuit B is left as it is. Okay. So Thevenin theorem says that this complex circuit, as we can see, this is a complex circuit because we are having one voltage source, one current source, three resistances in it. So we can convert this complex circuit into a single circuit which is having a single equivalent voltage source and single equivalent resistance. So to solve this question will be very easy. As we can see, we will be connecting the load B across this, and just by joining these two circuits, these two networks, we can easily find the value of current I, which is our objective, to find the current I in this particular branch, which is load resistance branch. So Thevenin theorem makes calculation of responses of circuit much easier. Now, before calculating the value of Vth and Rth, let us see what are linear and non-linear elements. So linear elements are those elements in which the element follows additivity principle and homogeneity principle at the same time. You can say that linear elements. Okay, so what is additivity principle? Additivity principle states that if I am having input as x1t and output to this is y1t, and if I am having another input, that is x2t, to the same system 1, and the output will be y2t, then if I add these two inputs, x1t plus x2t as input, if I provide x1t plus x2t as input to system 1, then output I will get is y1t plus y2t. This is additivity principle. Similarly, homogeneity principle can be stated as, if I apply input x1t to system 1, and then I'll get value y1t. But if I multiply this input by a constant, that is k, then in the output I'll also get the value of y1t multiplied by this same constant k. This is homogeneity principle, and any element which follows the additivity principle and homogeneity principle in one at the same time, the element is said to be linear. Otherwise, it is non-linear element. Now, talking about unilateral and bilateral elements. The elements in which the direction of flow of current does not affect the voltage and current relationship are bilateral elements, and those elements in which the flow of currents, the direction of flow of current affects the voltage and current relationship. As we can see in resistance, the direction of flow of current does not affect any kind of VI relationship. It remains same. So this is bilateral element. But in diode, the direction of flow of current, that is, if current is flowing in this direction, then the current will flow, but in an opposite direction, the current will not flow. So this is unilateral, because it is affecting the VI relationship when we are changing the direction of the flow of current. Now, Thevenin theorem, it states that any linear bidirectional circuit having more number of active and passive elements, it can be replaced by a single equivalent circuit consisting of equivalent voltage source and equivalent resistance. So we can say that we are having a linear complex circuit, and this complex circuit can be replaced by a single equivalent circuit consisting of equivalent voltage source, that is Thevenin voltage, and equivalent current, and equivalent resistance, which is Thevenin resistance. And a load is connected to this particular element. Okay, load is connected to this circuit, and we can easily calculate the value of current I here, which is desired value. So to calculate the value of RTH and VTH, let us see what kind of methods we have to apply. So first, rearrange the given circuit in the form of two networks, that is A and B. Separate the network B. These two we have done. To simplify the network A, we need to find the value of VTH and RTH. And how to find the value of VTH? Define open circuit voltage across the terminals of the network A, and this voltage is Thevenin voltage. And we can calculate this Thevenin voltage by applying KVL. And to calculate the value of RTH, that is Thevenin resistance, we have to replace all the independent sources with their internal resistances to form an inactive network, and calculate the equivalent resistance across the terminal of network A. Okay, this whole thing is okay, but what is meant by this statement? Replace all the independent sources with their internal resistances. So, to replace the independent source with the internal resistances, we have to know that what are internal resistance of various kind of independent sources. So if we are talking about an independent voltage source, it looks like this, and if we are talking about a current source, it is represented as this, the current I and the voltage P. Now, coming on to the practical circuit of this voltage source, we can say that this is minus plus, and this is R internal is the value, which is resistance, internal resistance. And here, coming on to the practical source, practical current source, the equivalent circuit is drawn as this. It is having value R internal. Now, the current will be flowing in this direction across the source, and maximum current needs to be flown in this direction only. So we can say that R internal needs to be very less or minimum. Coming on to this current source, maximum current also here in this case to be flowed in this direction. So minimum current needs to be flown in this direction, or very less or no current can be flown in this direction, because maximum current is flowing in this direction. So the R internal value will be very large in this case. Hence we can say that R internal is approximately equal to 0 in this case, in the case of voltage source, and it's approximately equal to infinity in second case, that is current source. So we can replace the internal resistance by a short circuit in voltage source and represent an open circuit in case of current source. Now, to find the current in 2 ohm resistance by using Thevenin theorem, we are having one question. So this is the load resistance, that is RL, and the current here we have to find is I. So we have to divide this particular circuit into two parts. Then we can say that to calculate the value of VTH, to calculate the value of Vth, we can say that we are having this particular circuit in front of us. So this voltage is VAB. This voltage is VAB. So we can write as VAB equal to open circuit voltage or the Thevenin voltage. We have to determine this particular voltage only. So coming on to this particular current source, the current source is sending a 20 ampere current in this direction, and then it's getting divided into two parts. One is 9 ohm, another is summation of 3 ohm and 6 ohm. As we can see, no current will be flowing in this particular branch, that is of 10 volt voltage source. No current will be flowing. The current will be flowing in 3 ohm branch and 6 ohm branch. So these two in series can form 9 ohm branch, and both the resistances are having 9 ohm, similar resistance, so current will be divided equally. So we can say that 10 ampere flows in this direction and 10 ampere flows in downward direction. So as we know that 10 ampere is flowing across 6 ohm resistance from top to bottom, so we can set the polarity as positive and negative, because current will be flowing from higher potential to lower potential. Now if we are applying KVL here, by applying KVL starting from this point, moving towards this, and then returning back to this particular point. So we can say that starting from here going towards this, so we are experiencing a voltage gain of 6 into 10. As we can see, 10 ampere is the current and 6 is the resistance. So I into R is the voltage gain. Then plus 10 volt equals to VAB. This implies that VAB equals to 70 volts. VAB is equal to 70 volts. And same is the value of VTH. Now, to calculate the value of RTH, to calculate the value of RTH, we can say that we have to replace this voltage source by a short circuit, and we have to replace this current source by an open circuit. Hence, the diagram is shown here. Now, to calculate the equivalent resistance as seen from here, we can see that the 5 ohm resistance does not affect much because it is connected with an open circuit element. Now, the 3 ohm resistance and 9 ohm resistance are in series in parallel to 6 ohm resistance. 9 ohm and 3 ohm are in series in parallel to 6 ohm. So we can say that 9 plus 3 equals to 12 ohm in parallel to 6 ohm. So RTH or R equivalent can be written as 12 into 6 over 12 plus 6, which is equal to 4 ohm. Now, to calculate the value, we have to draw a particular circuit that is consisting of one equivalent voltage source and one equivalent resistance, and one load resistance RL. Here the value of RL is 2 ohm. Here the value of VTH is equal to 70 volts and value of RTH is equal to 4 ohm. To calculate the current I, in this branch, I can say that I equals to VTH over RTH plus RL, which can be equal to 70 over 4 plus 2, which is equal to 70 over 6 ampere. Now the calculation of Thevenin equivalent circuit parameters, that is VTH and RTH, when dependent sources are present. Till now we are studying about the sources which are independent in nature, but now we'll be studying about dependent sources. So initial methods of calculating rearranging the circuit and separating network and simplifying network are same, and even the calculation of voltage is same by applying the KVL, but the difference is in the calculation of RTH. we have to replace all the independent sources with their internal resistances to form an inactive network and leave dependent sources as it is. Now, short circuit the terminal of network A and reduce the current ISC, that is short circuit current. We have to leave dependent sources as it is, first point, and then short circuit the terminals of network A and reduce ISC current. And when we are able to reduce the value of ISC current, we know the value of Vth, so we can easily determine the value of Rth. Okay. So let's see a question here in which we have to determine the value of Vth and Rth, because the question is asking the Thevenin equivalent of given circuit. We have to determine the Thevenin equivalent of given circuit, and it means that we have to determine the value of Vth and Rth. Okay. So to calculate the value of Vth, we can see that this circuit is having a closed loop here. This circuit is having closed loop. This circuit is open circuited. Now, across this current source, this dependent current source, we are having value Vx as its potential. Okay, and the current flowing in this branch, as we can see, the current flows in this branch. So current flowing in this 2 kilo ohm branch is Vx over 4000. Vx over 4000. So by applying KVL, we can see that starting from here, we are having a voltage gain of Vx, then we are having a voltage drop of 2000 into Vx over 4000 minus 4 equals to 0. This implies that Vx minus Vx by 2 is equal to 4. This implies that Vx equal to 8 volt. So I got the value of Vth is equal to 8 volt. Now to calculate the value of Rth here, now to calculate value of Rth, we have to replace this voltage source by a short circuit element, and we have to cover this whole circuit. As we can see, we have to short circuit the terminals of the network A, and let us say ISC current flows in this branch. So we have I've redrawn this particular circuit. Now the current flowing in these two branches, current flowing in is Vx over 4000, which gets distributed unequally in two branches. Okay, so to determine value of ISC, we need to follow current divider rule. So current divider rule states that the current which is to be determined in a particular branch is equal to the total current into the resistance of opposite branch divided by the sum of the total resistances. So we can say that ISC, which is equal to Vx over 4000, which is the total current, which is multiplied by 2 kilo ohm, which is the resistance of the opposite branch, upon 2 kilo ohm plus 3 kilo ohm. So from here, I can get the value of ISC as Vx over 10,000. Vx over 10,000 is equal to it is equal to 8 over 10,000, as we know from previous 10,000. As we know from previous part that Vx, that is Vth, is 8 volt. Okay. Now to calculate the value of Rth, Rth is equal to Vth over Isc. So here Vth is 8 and Isc is 8 over 10,000. This implies that Rth is equal to 10 kilo ohm. So we have determined the value of Rth, we have determined the value of Rth, we have determined the value of Vth, that is 8 volts. So we can redraw this circuit. We can redraw this circuit in a form as this is R, this is voltage, and this is the circuit here 10 kilo ohm, and this is having value 8 volt. So this is the Thevenin equivalent circuit. Now in the following cases, Thevenin theorem cannot be applied. Now what are these cases in which the Thevenin theorem cannot be applied? We can see here as in first case, that is when the value of the dependent sources depends on the load component. Value of dependent sources, that is VL, which is depending on the load component. Yes, this one. If this kind of case is occurring, then we cannot determine the value of we cannot apply Thevenin theorem. Thevenin theorem is not applicable. Now, when unequal value of frequency of sources are present, if we can see that if we are having value 1 as V1t as sin t and V2t as sin 5t with different sources, they are sin t and sin 5t. So frequency is totally different in these two cases in a same circuit, then we cannot apply Thevenin theorem in this case also. Okay, so thank you all, and please like, share and subscribe this channel, and please let me know in comment section if you have any doubt. Thank you.